Okay, so you can hear me. Okay, so today we will start with some of the concrete classifiers uh, and how they work. Okay, and we'll start with decision tree first and try how it is created. Okay, and at the end we will also look at what is the difference between practical implementation and the theory. First, we will look at the theory part and see how various decisions are made. Okay, so you can't hear me? Can you hear me or not? Hello? Okay, I think you can hear me then, right? Okay, so we will start with the decision tree classifier today. All right. Uh, so it's a classifier. That means uh, it's a model or it's a way to classify or to find out the class given a set of attributes or set of variables. Okay. So so obviously the model will learn something from training data. So it is a training data. So model will learn some structure or some model. So in this case, it's a tree model. So it will learn a tree model in this case of a decision tree. From the name, it's obvious. It is a decision tree. So it makes decisions at every node of the tree. Okay. So you might have seen such trees already somewhere. So how they look like is that they make some binary decision at each point, whether yes or no, depending upon the result of yes or no. So what we'll do, we'll check for the attributes value or the variable or the features value. Okay, and depending upon what is the value of the feature, it will either take a left or right direction. Okay, whether it is yes or no, or maybe some other binary attribute, a binary value, and then again it will keep on making the decision until it is sure that now at this point of time when it has enough information, it should stop and it will tell you, okay, this class, the class of this example should be this. Okay, so how to make this tree, how to create this tree is what the decision tree classifier means. Okay, how, or you can say decision tree induction. Okay, so how to make a tree that can make decisions based upon the input, some input examples. So any input will consist of a lot of attributes, the given attributes, some values of the attributes. Okay, and then based upon those values, the classifier can, given that you have created the classifier, you have already trained it, so the tree has been made. Now you just have to look at, start from the root node and then reach one of the leaf nodes where it will stop and tell you the class of this particular example that you have given it. Okay, so but how to create that tree itself is what we will learn today. Okay, how the model is created. So these are definition that you can find in the reference book for the decision tree induction. That is how to create the decision tree. Okay, so it's as it is mentioned here, it is like a flow chart. So like a flow chart, and at each node you make certain decisions, right? And based upon the output of that the decision, you make the next decision. Okay, and you keep on doing that until you are satisfied with the output. Okay, so maybe in the case of tree, until you reach, you want to continue until you reach a leaf node. Leaf node means when you can make, when you are certain that okay, the class should now be this. Okay, maybe it's positive class or negative class or some other thing. Okay, or you may try to stop just before that when you have when the number of remaining attributes in which you have not yet made a decision they become below something, you can stop there also. Okay, and then looking at the in the examples, looking at which has the maximum value, which has the maximum class, that majority will be the class of the or the label of the example. So don't worry if you are not understanding right now. It's I'll give examples and it will be very clear after that. So if you want to just continue doing creating tree until leaf node until you have a single class left, then that will be a terminal node or the leaf node. Okay, in which case that leaf node will have a single class. All the examples, all the samples there will belong to a single class. Okay, but if you want to stop early, and that happens often, that you want to stop before going to the leaf node. Okay, we will learn about the overfitting of decision tree later on. So in that, you don't want to continue creating tree until you reach a condition that every sample belongs to the same class. Okay, you want to stop before that. You may have some samples which belong to different class. Okay, so some of the samples belong to class A, some other samples belong to class B. Okay, or positive or negative. Okay, you have mixed, but majority of them belong to some class. So you want to stop early. All right, but right now today we will study how you create a complete decision tree. Okay, and if you want to stop early, that's called pruning. That we will learn later on. So it's a very simple algorithm, decision tree. So let's say look at one particular example. Then we will also implement this. Okay, in Python, so that it is clear to you what are the different how the practice is different from theory. Okay, so we are just learning theory right now. Okay, when you implement this in Python, you will see that you have to make certain you have to make certain assumptions and convert some data set into some different form. Anyway, so this is the idea. This is a table that contains 14 examples, and you want to create a decision tree from this example. So here the class is whether a person will buy a computer or not. Okay, you want to create a decision tree, okay, that can be used to find out whether a person will buy a computer or not. Okay, and depending upon these are the attributes. So age, income, student, and the credit rating are the 4 attributes that you have at your disposal. Okay, the first if you look at the first column here, it is just a index. Okay, it's RID, just some index. Don't use this. Okay, it's very important not to use this kind of data. You just remove the index. It's just for your reference. Okay, reference ID. So don't use RID as an attribute. It's just a serial numbers. The 4 attributes are age, income, credit rating, 4. Okay, and then there is one class, that is whether a person will buy a computer or not. So if you look at the first sample or the first example here, so here the income is high, the person is not a student, the credit rating is fair, the person is youth, income is high, not a student, and credit rating is fair. So in that case, in this particular example, he didn't buy this particular person didn't buy a computer. So no. Okay. The second one is youth, high, no, but here the credit rating is excellent, but still he didn't buy a computer. Okay, so you can see that there is difference between first and second example in the credit rating. Okay, so even that there's some difference in the credit rating, but still the person didn't buy a computer. So some such examples are given. So there are total of 14 examples. It's a very toy, not even a toy data set. It's just a small learning data set. Okay, just for learning purpose. In reality, you'll have thousands or millions of such examples in your data set, and the features will also be quite large. Now you want to create a decision tree. So what decision tree does is, first of all, it will try to see on which attribute it should make the decision first. Okay, which should be the first attribute on which it should make a decision, so that finally the accuracy of the classifier is maximum. Ultimate goal is you should have maximum accuracy, right? You don't want 100% accuracy, but you want some maximum as much as possible, highest accuracy. Okay, that is F1 score or whatever measurement you are using. Okay, so let's say for the sake of it, let us say the first somehow you found out. So there are techniques to find out which attributes should be used to make decision at each point. Okay, so let us say by using some other method, you found out that okay, the first decision should be made on attribute called age. Okay, it's the first attribute. So I just took age as the decision. Okay, but ultimately when the decision tree is created, okay, the decision will be made based upon certain algorithm, some method. Okay, so let's say they based upon that method, age has found to be the best attribute on which you should make a decision at the beginning. Okay, so this is called splitting criteria. Okay, attribute splitting criteria or attribute selection criteria. So you have algorithms for that. You will see about entropy today, and maybe you will look at Gini based attribute selection later on. But today we'll look at entropy based. Okay, so in that you check for each of the attributes which are available right now, and based upon that, based upon entropy, you find out the best attribute to use at that point. Okay, so let's say by using that method, you got age as the first attribute. Now here the age could be youth. I'm just writing why for it. Okay, age could be middle aged, or age could be senior, old person. It could be one of the three possibilities. Okay, now that you have made a decision, let's take the first leftmost case when the person is youth. Okay, let's say you made decision. Okay, let's say this has got we only want to pursue this case. Okay, other cases also you have to do, but right now just focus on only youth. Okay, now you have already made a decision based upon age. Okay, that means, and you're looking at that split in which the examples have age is equal to youth. Okay, so that means which are the examples of youth in which age is equal to youth? So that is first, second, 8th, 9th, 11th. Okay, so these are the 5 examples where the age was equal to youth. Okay, so now because you have already reached this particular, okay, this will be square here also. Okay, you have already reached this particular point where you have already made a decision based upon age. Okay, so that means, and age is equal to youth. So all the examples will be youth here only, right? So you don't have to again reconsider age. So in any path of the decision tree, once you have made a decision, so in this path you will not again consider age. So age is gone now. Okay, age is youth. You know that age is youth obviously. Okay. So now you have 3 more attributes left. Okay, and again you will apply the same method, attribute selection criteria, to find out which of these remaining 3 should give you the best result at that point of time. Okay, so in this case it could be something. Let's say by applying that method, you found out that maybe income was the best attribute at this point among the remaining 3. Like income, student, credit rating. So again you see what are the different features of what are the different values of income. So you have low, medium, high, and then you'll again make a split, 3 splits, right? Low, medium, and high. And let's look at the left, the low income case. In which case again you have to make one more decision. You have 2 more criteria. Okay, now at this point of time, you also look at how many classes you have, or the examples, they belong to how many classes. Okay, at any point of time, let's say here in case of at the top. Okay, let's look at the top here. Let us say there was a case in which all the classes, all the examples when age is equal to youth, let's say the classes all were yes. Okay, in this case what happens? Now all the examples are yes, so you have to stop here. Okay, because all the examples belong to a single class. So here you just output that class will be equal to y in this case. Okay, if this is only a hypothetical example, not in this case. Okay, so we'll stop if all the examples belong to a single class at any point of time. Okay, or otherwise you'll keep on splitting until you reach a leaf node. So you'll stop either when you reach a condition in which all the remaining examples, they belong to a single class, or you reach a leaf node. That is, there is only one example left, so obviously that will be the class. Any doubt? Okay, so in this case, let us say this is the decision tree which has been created. Okay, so first it was split on age because it was found to be the best criteria based upon certain method. Okay, and then if the age was youth, then the second best criteria after that was student, whether the person is student or not. Okay, and at this point of time, the person is a student, then the class would be yes. Yes means the person will buy a computer. And if the student is no, the person will not buy a computer. Okay, so when you reach this point of time, this condition, in here you know that the person is a youth but not a student. Okay, right? Because you have followed this particular path from the root, starting from the root. So age was youth and not a student. Okay. And if in the beginning itself, okay, if the person was say middle aged, and then you know that the person will buy a computer immediately. Okay, maybe the examples was such that in this case, if the person was middle aged, all the examples they have bought computer as yes, buy computer as yes. So you know that if the person is middle aged, you don't require any other split, any other checking, he will buy a computer. So yes, there itself. Okay, so you'll keep on splitting until you reach a case where you are sure that this is the class. This should be the class. And the first splitting criteria that you will, the first of the splitting criteria that you will study is called information gain or entropy based. Okay, you can just say it's entropy. So entropy of any data set, you can find entropy of any data set is given as minus summation of P log P. Okay, for all the different classes. Okay, we'll see the example for this to make it clear. Okay, so Pi log Pi, where I is from 1 to number of classes. Okay, so Pi is the probability of an example belonging to that particular class. Okay, so it's just a numerical division. Okay, so if so let's look at one example, that same example here, the bias computer. Okay, so what will be the initial entropy or initial information? So entropy means how much information is required. Okay, how much information is required to make a decision. Okay, or you can say how much disinformation is there in the system right now. So if entropy is high, that means there is a lot of disinformation, or you can say you require a lot of more information. Okay, so the initial entropy can be calculated by looking at how many examples belong to yes and how many examples belong to no. Okay, so you can see that no has 1, 2, 3, 4, 5. Okay. So there are 5 examples out of 14 which belong to class no. That means 14 minus 5, 9 will belong to yes. So 9 belong to yes and 5 examples have no as a class. Okay. So entropy formula here you can see is minus pi log pi, where m is the number of total number of classes here. Okay. So here we have only 2 classes, yes and no. Right. So for yes, what is the probability? For no, what is the probability? So for yes, the probability is minus p log p, just using the formula. Okay. So what is the probability of? So probability you can find just by looking at the numbers, right? So there are 9 yes out of 14. So 9 by 14 is the probability of a random person buying a computer, right? If you don't have any other information, so what is the probability that a random person out of these 14 will buy a computer? So because there are 9 persons who have bought computer out of 14, so probability is 9 by 14. Okay. So minus p log p will be minus 9 by 14 log 9 by 14. Remaining 5 persons have not bought computer, so for them also you have to calculate. So for every class you will calculate the entropy. So minus p log p again. So there are 5 out of 14 who have not bought. So minus 5 by 14 log 5 by 14. Okay. So basically summing them up because there is a minus sign, you are just writing minus here. Okay. So in the formula you have minus sign. Remember, there is a minus sign here, and because of this, the output will be positive. Okay. Otherwise, p log p, because p is less than 1, so it becomes negative. Okay. So negative of that becomes positive. So this will ultimately be some positive number between 0 and 1. Okay, it will be 0 or some positive number. So the initial entropy here is minus 9 by 14 log 9 by 14 minus 5 by 14 log 5 by 14. So you can always ask some questions if you have any doubt at any point. So is it clear so far? Yes or no? Okay. So information or entropy part is clear, right? Minus p log p. Okay. And this you will find for every class. So right now initially you have only 2 classes, no one yes. So just initial entropy is minus p log p. Okay. Okay. Now let's look at how you select which attribute should be used to split first, which should be at the root node, and then after that the next. Okay, which are the attributes that you should be looking at. So let us look at each attribute one by one and find out its entropy. Okay, find out the entropy if that attribute would be used to split. Okay, if that attribute is selected, what would be the resulting entropy of the system, whether it will increase or decrease. Okay, so you will select that particular attribute, okay, which is the least entropy. Okay, so you'll find entropy, you'll calculate entropy for each split based upon each attribute, say based upon age, based upon income, based upon student, based upon credit rating. Okay, and then out of these 4 entropy that you have calculated, you will select the one that will give you that has the least value of entropy. Okay, so select the least one. So if there are 2 attributes which have same value of entropy, then you can select either of them. That is not an issue. Okay, let's look at the part of age. Okay, let's calculate the entropy if you split on age. So if you look at the formula again, this is the formula for splitting, for calculating the entropy or the information that is present, this information that is present in the system, or you can say this will represent how much more information is required if you split on that particular criteria, that particular attribute. Okay, provided that you split on that particular attribute, what will be the resulting disinformation, or what is the resulting entropy? Okay, so right now we are considering. Let's look at the attribute age. Now age has three different values. Right? There is a youth. So how many youths are there? 1, 2, 3, 4, 5 youths are there, right? So 5 youths are there. How many middle-aged persons are there? 1, 2, 3, 4, 4, right? And that means the senior will be how much? 5. 1, 2, 3, 4, 5. Correct, right? That means okay. So let us look at what happens if you split on age. Okay, then you have to look at three cases. So if you split on age, there will be a three-way split, right? It will be split on youth, split on middle-aged, and then one more senior, right? So there are three cases you can take. Okay, so what is the probability that provides that age is used to split? What is the probability that any random example, okay, belong to youth? Can you write? What is the probability of youth? So you have a total of 14. So what is the probability of splitting on youth, or youth getting selected out of 14? So 5 by 14, right? So 5 by 14 is the probability of youth getting selected. 4 by 14 is the probability of middle-aged person getting selected, and again 5 by 14 is the probability of senior person getting selected. Okay. So let's look at youth first. Okay. Now provided that you select youth, okay, then what is the entropy of the system? If you split on, let's say if the split is made and then you are going to youth direction, then what will be the result? What will be the entropy of the resultant system? That means now you'll only consider those examples that have youth in that. Okay. That means okay, I'll change the color. So first example has youth, second example has youth, third, fourth, fifth. Sorry. So first, second, 8th, 9th, 10th is not there, 11. Okay, so 8, 9, and 11. So these are the examples which have youth in that, 5 of them. Okay, so let's only consider these examples now and look at what the entropy of this particular system. Now entropy means how much disinformation is there. Okay, so now if you look at these 5 examples, you can see how many of them are no and how many of them are yes. Okay, so how many of these are no and yes? So you can see that there are 3 no's and 2 yes. Right? So entropy again you can calculate in a similar way like you calculated earlier. So out of these 5 examples, 3 are no, 2 are yes. Okay, so again you apply the same formula, minus P log P. So minus 3 by 5. Remember now you are looking only at the 5 examples. Minus 3 by 5 log 3 by 5 minus 2 by 5 log 2 by 5. So you are using base 2 log here. Remember, it's not base 10. Okay. So this you are multiplying by 5 by 14. Similarly, the probability for middle age was 4 by 14. So you multiply this by the probability when the middle aged examples were selected. So you can see you are applying this same formula here. You are applying this formula that is given here, that is dj by d. Okay, so dj is how many examples belong to that particular value of the in the data set, in the remaining data set, whatever data set you have at the moment. Okay, so right now you had the complete data set so far. So out of that 5 have youth. Okay, so now we are calculating for that 5. So 5 by 14 into the entropy for that, provided that you have selected that j, then what is the entropy of that? So that you got 3 by 5. Okay. Then similarly, what is the probability of middle-aged person getting selected? 4 by 14. Okay, and then provided that you have selected those 4 examples, out of those 4 examples, what is the entropy of that system? What is how much information is required more? Okay, so again you apply the same formula minus p log p. So look at the 4 examples which have age is equal to middle aged. So middle aged, middle aged, middle aged, and middle aged, right? So you can see that all 4 are yes. There were 4 middle aged person and all were yes. So in this case the entropy should be 0. Okay, and we will see that if you calculate entropy it will come 0 because all 4 are yes. So if you calculate entropy it will be minus, for yes it will be minus 4 by 4 log 4 by 4. Okay, and for calculating entropy, remember that log 0 is considered as 1 minus 0 into log 0. So that is 0. Okay, so log 1 becomes 0, right? And this entire entropy becomes here 0. And that could be the reason if you look at the earlier case. Remember when the age was middle aged, immediately said that in the decision tree it was said that the person will buy computer, and that you can say here why it happened, because when the middle aged was the case, when the person was middle aged, because entropy is 0. That means entropy 0 means all the examples they belong to the same class, that is, and the class here is yes. Okay. So when all the examples belong to the same class, and that class is the output. So in this case, immediately the output should be yes. So that class should be the label that you should give to the example. Okay. That means no misinformation. Yes, no disinformation or misinformation. Okay. You don't require any further information. Okay, when all the examples they belong to the same class, that means you don't require any further information because you have all the information required, because all the examples they belong to the same class, so you just can classify that particular case as whatever class they all belong to. Okay, in this case they all belong to yes. So in this case you have all the examples which belong to class buy computer, so you know that in this case they will buy computer. You are sure, 100% sure. Okay. And you can also use the formula minus p log p to see that that will be the case, right? Because when every example is of the same class, then minus p log p will become 0. Log of 1 is 0. Okay, one more thing before we proceed. When do you think will be the maximum entropy? When will the system have maximum entropy? When the system will have maximum entropy? So I will clear this thing. Let us say you have 14 training examples, not this particular table. Let's say some different data set in which you have again 14 examples and 14 classes, yes and no. Okay, and you want to find out the initial entropy. So what could do the and you know that maximum entropy can be 1. Okay, so when is that the case? When is the entropy 1? The maximum entropy when you cannot make even a small decision based upon that condition. Okay, so right now, so when will the what will be the when will be the case when you are the most unsure about the class, which class it should go to? Let's say you have say all 14. Let's say you have yes. Okay, so is there any misinformation there? Whether something is there anything missing there? There is nothing, right? You have full information. So in this case, entropy is 0. What if you have divided them, say 10 yes and 4 no? Now in this case, you have slight information, right? You know that there are more yes and 10 yes and 4 no's. So there's more, is more inclined towards the yes, right? So if you have to make a decision right there, you'll say yes, because that has more probability, right? So you can see that here the information, the entropy of the system here when it was 10:4 is more than the entropy when it was all 14 was yes. Okay, but you can further increase it, right? What if it is say 8 and 6? So out of 10:4 and 8:6, which is more convincing to make a decision? 10:4 is more convincing, right? If you have this case 10 and 4, 10 yes and 4 no's, or 10 no's and 4 yeses, in this case you can just look at the majority and you can say, yeah, 10 is is more than double of 4. So this you say, okay, the class would be, if you have to make a decision, you will say, okay, yes or no. Okay, so if 10 is yes, you will say yes. But when it is 8 and 6, then you are not so sure, right? Then there's the no also has 6 examples. So the entropy has increased. So you can say that information further required has increased. You require more and more information. Okay. And when the examples are equally divided, 7:7, in this case you have the least information because you don't know anything. None of them has a majority. Okay, right? Up to 10:4, 8:6, one of them has a majority, so you still could decide. But when they were equally divided, 7:7, now you don't have any information. Okay, you require a lot of information after that. Okay, or you can say the entropy is maximum when these are equally divided, and you can see that that will be the case if you put these in the formula. So you'll see that minus p log p, so minus 7/14 log 7/14, and again the same thing will repeat, minus 7/14, because yes and no both have 7/7, or you can just multiply by 2 here. Okay, so it is like minus half log half, minus half log half into 2. Okay, so these 2 cuts here, and log half is 2 to the power minus 1, so that is 1, so that will become 1. Okay, that is the maximum entropy. So entropy is maximum when there is more uncertainty in decision making. Okay, or you can say there is much more impurity in the system. Okay, because they are quite evenly distributed. Okay, you cannot make a decision, any decision right now. You require further splits or further information. Okay, so when they're equally divided, the entropy of the system is maximum, or entropy of that particular case is maximum. All right. So the initial entropy was 0.94. Okay, and initial case was there were 9 yes and 5 no's. So when you calculate this, it comes out to be 0.94. Okay, that means you require a lot of, so it's quite high entropy. I require quite a bit of information. So once you split on age, okay, what will be the entropy of the system, or entropy of the system after this split once you split on age. Okay, so if you say split on age, so age has three cases: youth, middle aged, and senior. Okay, so you have to find entropy for all of them and sum them up. The entropy of the system after the split will be sum of these entropies. Okay, so we will look at the entropy for youth, entropy for middle aged, entropy for senior, and we saw that how to calculate these entropies. Okay, so for youth, so to calculate the entropy, what you have to do, first of all, you have to find the probability. Okay, so 5 by 14 is for probability for youth. Okay, and out of these 5 by 5 youths, they were divided into 2:3. 2 belong to one class and 3 belong to other class. So the entropy for that 5 youths is calculated here. Okay, when it was middle aged, all of them were yes, so obviously you got 0 here. Okay, and this will give you the value of 0. So there are 4 middle aged, so 4 by 14 is the probability multiplied by the entropy, so that becomes 0. So for middle age it is 0, and for seniors again there are 5 seniors. These 3, and one senior is here and one is here. Okay, so you can see that how many years are there? 1, 2, 3. So 3 years are there. When you select senior, so that is 5 by 14. 5 seniors are there, and in these 5 there are 3 years and 1 no. So 2 no, sorry. So 3 by 5 log 3 by 5 minus 2 by 5 log 2 by 5. So that is what you do at the end, and you calculate the entropy here. So it came out to be 0.694. Okay, just make sure that you are getting this result. If you want to quickly find this entropy by using Python, what you can do is you can import numpy. Okay, import numpy. Let's say as NP. It's a very common shortcut. NP is written for an numpy. Import numpy NP. And before that, what you can do is from underscore future. So remember, there are 2 underscores together, and then future, and then again 2 underscores. From future, import division. Import division. So this will basically allow you to perform floating point divisions. Okay, otherwise something like it is just discard the decimal part. Okay, so now, or you have to use .0 if you don't want that. So now what happens after that is, so for example, let's say 3 by 2. Let's say 3 by 2. So you just take it as 1. 1.5. So 0.5 is removed, so only 1. Okay, so it is integer division by default. So by using this, it becomes 1.5. It becomes float division. So now whenever you use division operator, you will get proper answer. Okay, and then you can use np dot log 2. Okay, just write log 2 together, and whatever log you want to find out. Okay, so for example, let's say you want to find log 3 by 5. Write 3 by 5 here. Okay, and you can type this in the computer much faster than you can type on, say, using calculator or something, right? And normally in calculators you don't have log 2 also, so it will be much faster to calculate by using in Python. Okay. So just in the prompt, whenever you open this idle, right, the ID, then you can just type this np.log2 to get log of log base 2. Okay, so for age you got 0.694 as the information that is required. Okay, and then same again you will calculate for same thing you will do for income, you will do for student, and you will do for credit rating. So you do this for all the attributes. Okay, of course in reality You don't have to do this, but you should know. Okay, the computer will do all these things for you, or the decision tree API will do these things for you. But this is the way in which they are doing this. If you are using entropy as the selection criteria, as the attribute selection criteria, so you look at it will look at all the 4 attributes, find the entropy, or if the split is done based upon that particular attribute, and if you select that attribute out of 4 to split, which gives you the minimum entropy. Okay, so here, if you look at the final answer here, you'll see that the gain on, okay, so here it is calculating gain. So gain is like if the split has the least entropy, that means it will have maximum gain, right? So gain is nothing but the initial entropy minus the resultant entropy. Okay, so if you look at this particular example, 0.694 is the entropy if age was used to select. Okay, and what was the initial entropy? 0.94. Okay, so what is the how much you have gained? 0.94 minus 0.694. Okay, so 10 out this will be 6, 13 minus 9 becomes 4, and that's 2. So 0.246. Okay, so the gain is 0.246, and that is what is written here. Okay, 0.246 is the information gain. It is also called information gain, but it is not required here because the entropy is, because the initial entropy is common for all. Okay, so and if the entropy is minimum, the resulting entropy is minimum, obviously the gain will be maximum. Okay, so you want to find, basically you want to find maximum gain, which split will give you the maximum gain, or conversely you can see that you want that split with the least resultant entropy. Okay, so in this case you will see that the maximum gain can be achieved by, out of these, when you use income. When you use income, oh sorry, not gain maximum, right? So gain here is maximum for age, right? Out of these, maximum gain is achieved when you use age to split. That is 0.246 is the maximum out of the 4 attributes. So you will select age to split. Any doubt? No doubt? Okay. And even without using gain, if you just calculate entropy, you would see that the entropy for the age is minimum out of these. Okay, and so you select age, okay, because this is result in the minimum entropy. 0.694 must be the minimum. So you select age. Now once you have selected age, as you mentioned earlier, once you select age, okay, then you have to make decision based upon all the remaining 3, right? So that means youth, middle aged, senior. So what is the entropy? So what is the next case? So let's say you have selected youth. Okay, what should be the next split? Whether you should split on income, whether you should split on student, okay, whether you should split on credit rating next. Okay, so that means now you have 3 more features left based upon which you have to make further decision, and so the tree will keep on growing. Okay, until you reach a case where either all the sample belong to the same class, or when only one sample remain, obviously that will belong to a single class. So let's stop this. So this is the complete tree, okay, without any early stopping criteria. Okay, but mostly in reality, in practical, you have to stop early. Okay, if you just create complete tree, then you suffer from, then this decision tree model will suffer from something called overfitting problem. Okay, that we'll look into later. Okay, similar to information gain, there is another criteria, another method to select a dispute. It's called Gini. Okay, so it's very similar to the calculation is very similar. Only thing the formula is here different. So instead of P log P, you find 1 minus Pi square for all P's. Okay, so we'll take a small break and then continue in 10 minutes.